Hi guys, now we're going to take a look at using formula. So the first thing we can do with formula is substitute values into it. So if a is 5 and b is minus 3, they might ask us to do something like this, which simply means 4 lots of a, so it's 4 lots of 5, minus 2 lots of b. Well, b is minus 3, so it's 2 lots of minus 3. And I'm going to just put that in brackets there, so I just think it makes it easier. So we've now got to follow BIDMAS, and because I introduced a bracket I have to do that first, but it's multiplication anyway, so we would do this above subtraction. So what I actually would saying is 20 take away minus 6. Double negative creates a positive, so it's the same as 20 plus 6, and therefore this answer is 26. Now b squared is minus 3 squared plus 3 lots of a, which is that. Now, they ask you this on calculator and non-calculator. On non-calculator, people don't normally make a mistake. On calculator, they do, because you trust them. But your calculator here will tell you the answer is minus 9, because it will do the indices before the negatives. And you should know that you don't need a calculator. Minus any number squared is always positive, because a minus times a minus is a positive answer. So this is therefore 9 plus 15, which is 24. And the last one, this is a classic question, lots of people get this wrong. This is 2 lots of a squared, which means 2 lots of 5 squared, which is of course 25 doubled 50. A lot of people do 2 times 5 and then square the answer to that, which would be 100. It's very, very different. Plus 4 lots of b, 4 lots of minus 3. So we're plussing 4 lots of minus 3, which is negative 12. When the signs are different, it means we subtract them. So 50 take away 12 is 38. Now, even on non-calculator, they can still be a bit of a pain and give you some more troublesome numbers. But this is just a fraction, and you know how to times and divide fractions. So AB, we can hide a multiplication sign in here, so that means A times B. So it would be 3/5 multiplied by negative 2. And if you want to turn this into a fraction, just put it over 1. So we have minus 6 over 5. Or, that is minus 1 and a 5th. And what we've got to do is take away 5 from it. So we've got minus 1 and a 5th, take away another 5. So minus 1 and a 5th. Take away 5, it's getting smaller again. So it's going to be minus 6 and 1/5. They're pretty harsh if they ask you something as hard as that, and it doesn't often come up. But I would, so be prepared for it. Now, a squared, this is a bit more annoying, but you know squared means multiplying by itself. Plus minus 2 squared. So that is 9 over 25, multiplying the tops and the bottoms, plus 4. Minus 2 times minus 2 is 4. Now, this is quite annoying because we're adding fractions. So, in fact, it's not annoying because you can just do that. That's just dead simple, isn't it? So, something less than 1 plus 4. There we go, it's done. I was going to make this 100 over 25 and then get 109 over 25, but that'd be pointless. Now, if it's not substitution, they're going to ask you to do some rearranging. And for these first ones, I'm going to make x the subject. So at the moment, the x is having something done to with the p, and because the operation is hidden, it has to be multiplication. When things are together, it means multiply, so we have to divide by p to get rid of it. And what we do to one side, we have to do to the other side. So if I divide both sides by p, that will cancel out, and there we have it. This case is actually a tricky one, because there's only one term with x's out of these 3 terms. It's this one here, but it's also a negative. So the first thing I'm going to do is add 2x to both sides, and I would have this, which means, because I want to make x the subject, I want it to be positive. So at the moment, we've got a 2-term combination. X is being doubled and then having 3. So the last thing that's happening is the first thing I'm going to get rid of. This is a positive 3, so I need to subtract it to get rid of it. to both sides, I will end up with that. And therefore, to get x on its own, if I've got two x's, I have to half everything. So if I divide that by 2, they cancel out. So I'm dividing that by 2, everything by 2. This one looks a little bit scarier, but it's dead simple. So x is being squared and then adding 3a's. So this is the last thing that's happening. So we need to get rid of a positive 3a by subtracting 3a. It's as simple as that. You just take away 3a's to both sides. Now, we have x being squared. The inverse is square rooting, so I have to do that to both sides. So, there we have it. Just square root everything. You could, if you wanted to, some of you will prefer this because this upsets a lot of people. If you square something and then square root it, it's the same. So, that's a more mathematically pleasing answer. But don't be afraid to put this one, it's absolutely fine. Now this is tricky because the x is sort of mixed up. But with multiplication you should know that that is the same, which means that this is the same. You can multiply in any order you want. So we can actually separate this x quite easily. So the x is being multiplied by 3z and then having p added to it. This is the last thing, it's a positive p. So I need to subtract it to both sides. So if you like, you can rewrite this as saying this is the same thing. So to get rid of a multiplying by 3z, we're going to divide by 3z to both sides, divided by 3z. So I'm going through this quite fast, but it's a revision video, not a learning video. Now this is the last case. They love asking you something as hard as this, because there's an x in both terms. So if it's going to be the subject, you can only have one of them. So when we have this, we have to think about writing it using an equivalent expression. The only way we can do that is introducing factorizing. And because it's in both terms, I can take it outside and form this. And therefore, this is multiplied by this bracket. So x is 6 divided by 5 plus y. So if you have a situation where there's something, well, the x or whatever you're trying to make the subjects in two terms, you have to factorize. Okay, there's two more I want to show you. They're pretty tough. I just need to fold this paper. So, in this situation, we've got a p as the subject, we've got p's all over the show. So we have to deal with this first. So at the moment it's being divided. I'm going to get rid of that, get everything on one line, because it's definitely going to make it easier. So we can times by p plus v. So with this side, it's being multiplied by p plus v. And if we multiply this side, I'll put it in brackets to make it easier, they will actually cancel each other out. We times to get rid of it. So this is what we now have. But now I've got a p here and a p here. So this is all mixed up at the moment, so I'm going to have to expand it just to get rid of it. So it'd be pq plus vq. So I'm just tidying it up. And now I want to make p as the subject, and I've got p's over here and over here. So they have to all be on the same side. I'm going to collect them here, so I'm going to get rid of this one. So I'm going to minus p to both sides, so I'll actually end up with this. And this hasn't got any p's in it at all, so I don't even want it on this side, so I'm going to minus a vq. So I've got minus vq and a minus a t. So I've got the p's all on one side, I've got rid of all the complicated division, but they're in now two terms, so I have to use my factorizing. So p times q is pq, and p times negative 1 is a negative p. And we're nearly done. We just divide now by the bracket to get rid of it. So minus vq minus t all over q take away 1. So that's a high grade rearranging one. Let's have a look at this one. So once again, I'm going to let's make x the subject. It doesn't really matter which one for this. But now we've got 2. If you think about what I did before, to get rid of this divide by 4, we times by 4. So that's what I'm going to do. I'm going to times by 4 first. So I've got 4 times x over p plus 2. Now keep thinking about your fractions. This is a fraction. If you're timesing it by a number, that is the same. So you will have this. It's timesing by 1 doesn't change anything. Now we can get rid of this by timesing by p plus 2, giving me this. Now, if I wanted to find either p as the subject, I'd have to expand this and then deal with it. So in fact, I'll do both. So for x as the subject, it's dead simple. I'm just going to divide by 4 because I've got 4 of them there. But if I wanted to make p the subject, let's just rewrite this one. I would have to expand this, get the term with p, get the term with p on its own, so I have to subtract 2r to both sides. And now I'm going to remove this r by dividing by r. I could write this in a slightly different way, but I'm not going to. So that's everything with